Hello, so in last class we have defined a universal set and properties P1, P2, etc. PQ on that universal set, and we have defined the quantities E of M and omega of M. So E of M denotes the number of elements of S that possess exactly M properties, exactly M of PQ properties, and we have defined omega of Pi1, Pi2, etc. Pim. So that will denote the number of elements. So this denotes the number of elements that possesses properties Pi1, Pi2, etc. Pim, and omega of M is the sum of omega of Pi1, Pi2, etc. Pim. So where summation is taken over all the M combinations. So where summation is taken over all M combinations of the set 1, 2, etc. Q. So this is the quantities we have defined in last class, and now we will see how to find out these quantities, and let us just verify the Peter-Knot principle. Peter-Knot principle inde namukku ഏതെങ്കിലും ഒരു value നമുക്ക് verify ചെയ്യാം means in this result. Okay, so you are given the table. So you are given the set S equal to the set 1, 2, 3 up to 6, and there are three properties P1, P2, P3 given. So some of the elements satisfy the properties. So there are elements that satisfy all the properties, no properties, and some properties. Given a property, all the elements may possess the property, or none of the elements, or some of the elements may possess the property. So that's how we define the properties. So let us look at the values of E of M first of all. Okay, so E of M means that denotes the number of elements that possess exactly M of the Q property. So there are three properties. So let us find out the value of E of 0, E of 1, E of 2, and E of 3. Now E of 0 is the number of elements that possess 0 properties. So that is the number of elements which possess 0 properties. So if you look at 6, you know that 6 possesses 0 properties. So therefore E of 0 will be equal to 1. Okay, so E of 0 will be equal to 1. So that corresponds to the element 6. Now E of 1 means that is the number of elements which possess exactly 1 property. So the number of elements which possess exactly 1 property will be here. If you look at 2 and 3, that will possess exactly 1 property. So E of 1 is going to be equal to 2, so that corresponds to elements 2 and 3. Okay, now if you look at E of 2, we need the number of elements which possess exactly 2 properties. Of 1 varum 4 varum. Okay, so that is again equal to 2, so that will be the elements 1 and 4. Now the number of elements which possess exactly 3 properties. So there is only one such element, so that is 5. So the answer is going to be 1. So it corresponds to the element 5. So that is the value of E of 0, E of 1, E of 2 and E of 3. Now let us look at the values of omega 1, omega 2 up to omega 3. Okay, so omega of 0, so by definition we have defined omega of 0 to be cardinality of S, so omega of 0 will be 6. Ini omega of 1 ennu parayunnathu, so we need to take the summation over all omega of p I1. So we need to take the all the 1 combinations. Appo namukku properties p1, p2, p3 ആണുള്ളത്. അപ്പോൾ ഇതിൻ്റെ എല്ലാ 1 കോമ്പിനേഷൻസും വരും. സോ ഒമേഗ ഓഫ് p1 പ്ലസ് ഒമേഗ ഓഫ് p2 പ്ലസ് ഒമേഗ ഓഫ് p3 വരും. ഇനി the number of elements which possess the property p1 ആണ് നോക്കേണ്ടത്. അപ്പോൾ p1 possess ചെയ്യുന്ന elementsന്റെ എണ്ണം. So the number of elements which possess the property p1 will be, so 1, 2, 3, 4 വരും. Okay, so omega of p1 will be equal to 4. ഇനി അതുപോലെ omega of p2 എടുക്കുമ്പോൾ that will be the number of elements which possess the property p2. So the number of elements which possess the property p2 will be 2. അതുപോലെ number of elements which possess the property p3 will be 3. So the values we need are 2 and 3. So plus 2 plus 3, so that will be equal to 9. Next is omega of 2. Omega of 2 is sum of all the 2 combinations. So pi1, pi2. അപ്പോൾ നമുക്ക് ഒമേഗ ഓഫ് p1, p2 വരും പ്ലസ് ഒമേഗ ഓഫ് p1, p3 വരും പ്ലസ് ഒമേഗ ഓഫ് p2, p3. 2 കോമ്പിനേഷൻസ് എടുക്കുമ്പോൾ നമുക്ക് ഇത്രയാണ് വരുന്നത്. Now let us look at omega of p1 and p2. So that is the number of elements which possess the properties p1 and p2. അപ്പോൾ p1 ഉം p2 ഉം possess ചെയ്യുന്ന രണ്ടും possess ചെയ്യുന്ന element എന്ന് പറയുന്നത് 5 മാത്രമേ ഉള്ളൂ. So that's the number of elements which possess the property p1 and p2. So that will be just 5. So 1 വരും. So 1. Then the number of elements which possess the property p1 and p3. So p1 ഉം p3 ഉം possess ചെയ്യുന്നത് 3 എണ്ണം വരും. 1 വരും, 4 വരും, 5 വരും. So that will be equal to 3. And the number of elements which possess the properties p2 and p3. അത് 1 വരും. കാരണം 5 മാത്രമേ ഉള്ളൂ. Okay. So that will be equal to 5. Now let us look at the value of omega of 3. So omega of 3 properties are ullu. Appo this will be omega of p1, p2, p3. Now we need the number of elements which possess the properties p1, p2 and p3. So p1, p2 and p3 possess ചെയ്യുന്ന ഒരെണ്ണേ ഉള്ളൂ. So omega of 3 will be equal to 1. And now let us verify the different values of E of M. So by generalized principle of inclusion or exclusion, so E of M is summation k equal to m to q, so minus 1 whole raised to k minus m kc m omega of kf. So let us verify the values of E of 0, E of 1, E of 2 and E of 3. So E of 0, so when m is equal to 0. E of 0 will be summation k equal to 0 to number of properties is 3. So minus 1 raised to k minus 0. Okay, from kc 0 omega of k. Okay, so when k is 0, you will get 0 c 0. So that is 1 of omega of 0 minus 1c0 into omega of 1 varum plus 2c0 omega of 2 minus 3c0 omega of 3. So E of 0 will be omega of 0 minus omega of 1 plus omega of 2 minus omega of 3. So E of 0 is actually 1, and when you take omega of 0 minus omega of 1 plus omega of 2 minus omega of 3, that will be equal to, so we have 695 minus 1, so that will be equal to 1. So the first result is verified. So E of 0 is 1. അതുപോലെ നമ്മൾ സമ്മേഷൻ എടുക്കുമ്പോൾ നമുക്ക് 1 തന്നെയാണ് വരുന്നത്. Okay, and next we have E of 1. So E of 1 is 2, and let us look at summation k equal to 1 to 3 minus 1 whole raised to k minus 1 kc 1 omega of k. So that will be kc1. Okay, 1 minimum, when k is equal to 1, you will get 1c1 omega of 1 minus 2 minimum 2c1 omega of 2 minimum plus 3c1 omega of 3. So that will be omega of 1 minus 2 omega of 2 plus 3 omega of 3 varum. So omega of 1 951 plus 3 into 1 varum. So that will be equal to 9 minus 10 plus 3, so which is equal to 2. So we have P of 1 equal to 2. അതുപോലെ generalized principle എടുക്കുമ്പോഴും നമുക്ക് 2 തന്നെയാണ് വരുന്നത്. ഇനി അതുപോലെ E of 2 is equal to 2. E of 2 ന്റെ summation എടുക്കുമ്പോൾ you get k equal to 2 to 3 minus 1 raised to k minus 2 വരും kc 2 omega of k. So when k is 2, you will get 2c2 omega of 2 varum and minus 3c2 omega of 3. So omega of 2 will be 5 minus 3c2 will be 3 into omega of 3 is 1, so that will be equal to 2. So E of 2 is 2. അതുപോലെ P0 principle നമുക്ക് ഇവിടെ തന്നെ വരും. And the last value is E of 3. By definition E of 3 നമ്മൾ summation എടുക്കുമ്പോൾ omega of 3 തന്നെ വരും. So it is equal to 1. So this is also verified. So this is how we define the properties. Then E of m and the omega values. So it will satisfy the generalized principle of inclusion and exclusion.